All right, welcome back, calculus students. We're gonna be looking at 8.4 part 2. My computer's been having recording issues. I guess the videos are making it a little too long. But we're just gonna keep powering through and work through these little issues. Okay. This is find the area bounded by the curves y equals ln x and y equals 1/2 x minus 2. So first thing, just like in the other one, I want to set them equal to each other. I want to find the x values, right, that I'm bounded between. So I'm going to do the natural log of x is equal to 1/2 x minus 2. So I run into a bit of an issue right here, because if I want to solve for x on the left side, I have to introduce a base of e. If I introduce a base of e on both sides, so look, check this out, e and then e, this is canceled out, and I get x is equal to e to the power of 1/2 x minus 2. Now the x goes back to the, or back to being an exponent. In this case, I don't know how to solve for an exponent because I now have to convert to the natural log again, and then it'll give me a cycle where I'm going back and forth, right? So I want to avoid that. So what I want to do is I want to type it into a calculator, see what does what. But I need to know which is my lower graph and my higher graph. In this case, I know just by sketching this, and again, like just from memory, that my ln x graph is something that looks like this, and my linear graph is something that looks like this. I'm trying to find the area bounded between there and there. So let's just type these into a calculator and see what my bounds are going to be. I need to find the intersection here, and I need to find the intersection here. So let's go ahead and pull up your calculator. In this case, I found a nice emulator that works. So I'm going to hit y equals, I already have these typed to save some time. Ln x, and then on y2, you're going to put 1/2 in parentheses to keep it as a fraction, x minus 2. I want you to click on window now and fix your windows. Copy my windows. I did it from -2, x min max 9, y min -4, y max 5, and I want you to hit graph, and your graph should look something like that. Now the reason my graph, the reason I chose that window is because I can see where it intersects on this side and a little bit before, and I can see where it intersects on this side and a little bit after. So I need to find the exact intersections. So let's click on second, and I want you to click where this button says trace. It'll give me that calc feature. So hit second and trace, and then go down to where it says intersect. Hit enter. So it says first curve. I'm confirming that my first curve is y equals ln x. So in this case, I want to make sure that my cursor is close to the first curve. So I'm going to say yes, or the first intersection. My y point, my second to my y2, my apologies, is that over here on this side. Yes, it's somewhere on there. Okay, perfect. I hit enter. Guess, yes. I want to guess the intersection around this area. Yes. So I hit enter. Oh, if your calculator, by the way, is not close to this side, you can shift it using the pads, right? Then hit enter, and then it will give me this intersection. So this intersection here is that x is equal to 0.145555167. Anyways, hopefully y'all took a little quick laugh. But okay, let's write that down. Let's write all of this down in our notes. So we're gonna go ahead and write that my first intersection point is x is equal to 0.14555555167. Shit, what else? Whoops, my bad. 155167. Okay, boom, perfect. 167. Perfect. The next one, I'm going to go back to my calculator, and now I'm going to do the same thing. Second, trace, go to option number 5. And then I'm going to, you see how my cursor is up here on my graph? Well, I'm going to slide it closer to the other intersection. As long as it's closer to the other intersection, I should be fine. So I'm just dragging it, moving it along. This emulator is a little bit older than your guys' calculators. So I have to be really close to it. For your calculator, as long as you're more than halfway, you should be fine. Now you hit enter. For Y2, you do the same thing. If it's still over here, you got to slide it all the way close, or at least more than halfway. So in my case, it's over here already. Am I trying to guess this intersection? Yes. So I hit enter. Boom. It's going to give me that intersection. That intersection is at A.2103332. Okay, so now I go back to my paper and I write x is equal to A.2109332. Okay, so now I have all of these decimal numbers. What do I have to do with them? I'm going to go ahead and set up my integral. But do I really want to write such a long decimal number for my lower bound and such a long decimal for my upper bound? No, I don't actually. I don't. For those of you that are ready to type those in, I'm going to go ahead and take this value and I'm going to label this as value A and value B. Okay? Because that's my A is my lower bound, B is my upper bound. So I go back to my calculator. I'm going to go ahead and save those values. So I'm going to go ahead and hit second, quit. I don't need my graph anymore. Second, quit. I'm going to type in my first value. So 0.14414555167. Yeah. Some of you are probably shaking your heads out like this dude. But anyways, you're going to hit this button that says STO at the bottom. STO, and it has an arrow. That stands for store. So I'm going to click on store. And I'm going to hit alpha. Because now I want to store that value as a letter. And we said that that's going to be A. So my green A is right here. So I'm going to click on A. I'm going to hit enter. So every time I type in an A, it's going to be this value. So now let's test this out. Alpha A, hit enter. Boom, it gives me the same value. Perfect. Let's do the same thing for B. I type in my next value. 8.2109332. Perfect. I'm going to hit store again. I'm going to save it under B. So alpha, this was A, so this one's B. So I'm going to save it under B. Hit enter. Again, just verifying alpha B. Enter. Boom. Okay, perfect. I stored it correctly. So now what you want to do is you want to evaluate it as an integral. So on your calculator, you want to hit math. Go to option number. Well, Alan says option number 9, Mr. Perfect. Yep, go to option number 9. I want you to notice, look at my option number 9 and look at your option number 9. My option number 9 does not have the same features as yours. Mine is a finite integral. So I have the finite integral, but it doesn't give me my place to type in the lower bound and upper bound. So guess what? You're going to do this next part on your own. For your upper bound, so when you create your integral, your lower bound is going to be A, your upper bound is going to be B. You type the A and the B, so that way you don't type out the whole decimal values. The natural log of x minus parentheses 1 divided by 2x plus 2 dx. And you should get a value of about, type that in. Make sure that your lower bound is an A, your upper bound is a B. Type that in, and you should get that you have approximately 8.74. Whoops, 8.784. 4. This is your answer. Okay, on your AP exam, if you have a calculator active problem and you get long decimal values, you're going to want to do what I just did here. If I was to cut my decimal values to 0.145 and 8.210, if I was to change that on my calculator, my final answer would not be this. My answer would be something like 8.68 something or 8.5 something. It would be completely wrong. On the AP exam, if I'm off by like a 1 or a 3, so like if this would have been instead of a 4, it would have been like a 3, or instead of a 4, I would put a 5. They would have possibly counted it correct. But if the 8, you have it as a 7, or you have it as a 9, or if this 7, you have it as a 6, or you have it as an 8, boom, automatically incorrect, because you didn't use the most numbers possible throughout your problem. Okay, so when you're looking at your problem and you come up with long decimal numbers, you are going to use all the long decimal numbers because they want your final answer to be as accurate as possible. Okay, so make sure that you use all decimals throughout your problem, and then once you get to the end, you cut it to that third place or that third decimal, and you should be fine. Okay, let's look at number 5. Okay, number 5, it says let R be the region bounded by the graphs y equals 2 square root of x, 2 times square root of x, and y equals x squared over 4 as the shown figure. If the line x equals k divides R into 2 regions of equal area, what is the value of k? So this one is telling me I have this area under a curve, but I'm just curious. I want to split this integral directly in half. What is this line k going to be? What is k going to be equal to? So don't be fooled. You can estimate it and you can see that it's going to be around 2, but we don't know if it's lower than 2 or higher than 2. So that's what we're trying to figure out. So if this whole thing, if this side is supposed to be equal to this side, then let's set up our integrals. So let's see. My integral is going to run between 0 to k. Make sure you write it small, by the way. This is going to require us to do a lot of math. By the way, what's the purpose of this problem and what's the reason behind us doing all this math? The number 4 is showing us how we would do this on an FRQ when we have calculator active problems. Number 5 is saying, okay, we're going to do another FRQ style type of problem, but instead, this one's not calculator active. Or this one in this case is not, how do I say this? This one, they want you to show the work, okay? So you will use a calculator, but not to like the very end, to the absolute end, okay? So here we go. When they ask you to show your work, this is what you got to do. So my function, I know my top bound is the 2 square root of x minus x squared over 4 dx is equal to k. My lower bound is k, upper bound is 4, and then the same thing, 2 square root of x is equal to, whoops, not equal. You're so tired? Yeah. Okay, mommy, rest for a bit, okay? Sorry, my daughter's right here while I'm recording, so you may hear her in the background watching her videos because she's watching cartoons while I record. But anyways, let's get back to our equation. Boom. So now it's bounded between 0 and k. So 0 and k, and then k to 4. You can see because my original is bounded between 0 and 4. So now, what happened, mommy? Okay, give me 1 second. Let me finish this and then I go get you something from the fridge, okay? Just a little bit. Wait for me. Okay, so I'm on a time crunch. Let's see. So from here, I want to take the antiderivative. By taking the antiderivative, I get 2 times x to the 3 halves times 2 over 3. How did I get this? Minus x cubed over 12. Hold on. I don't think I'm recording. Yes, I am recording. Okay. I panicked because I didn't see my recording light. So how did I get this chunk here? How did I get this chunk? Well, if you remember, the square root of x, that's the same thing as x to the 1/2. My antiderivative, I take x to the 1/2. I add a 1 to my numerator. That's going to give me x to the 3 halves. But then I have to divide it by the 3 halves. I don't want a denominator as a fraction, so I'm going to multiply by the reciprocal. So I get 2/3 times x to the 3 halves. Whoops, 3 halves, not 3/3. 3 halves. Okay, that's why I got that. Okay, some of you may have that question, so there you go. And this integral, or this, well, yeah, this antiderivative is being evaluated for my bounds of 0 to k. And that's going to be equal to the same thing on this side. 2x to the 3 halves times 2/3 minus x cubed, x cubed over 12. And this one's going to be evaluated between k and 4. Okay. So now, next part. I'm going to do some simplification. I'm going to do some simplification on this side, right? So if I do some simplification, I should end up with 4/3 times k to the 3 halves minus k cubed over 12 minus 0. Ooh, where did I get minus 0? Okay, so I want you to realize, do not put the parentheses in your problem. This chunk is when I evaluate this whole part with a k. This side, the 0, is when I multiply everything by a 0. Mommy, keep it down for a bit. Just, okay? Thank you, Mommy. Okay. So, do not put the parentheses. Sorry, she's playing with her toys and she likes to pretend like, I don't know. But anyways. So, I evaluated the left side to k and the right side with a 0. And that's going to be equal to, I'm going to do the same thing on the other side. I'm evaluating the 4 versus the k. So I got 4/3 times 4 to the 3 halves minus 4 cubed over 12 minus, again, this is literally a copy of k, right? Because we already evaluated at k, so k is going to be the same thing. I'm going to put it in parentheses so you see what's happening here. 4/3 k to the 3 halves minus k over 12, and k is cubed, right? Now, I want to transfer all my k's from the right side to the left side. I'm going to transfer all of those k's over. When I do that, I'm going to get 8/3. Again, this is just simplification of the left and right side. K to the 3 halves. 3 halves, not 3/3. 3 halves. Minus k cubed to the 6th. Or k cubed over 6. And that's going to equal to, well, if I simplify this side, I should get 32/3 minus 64/12. Okay, this is where I got to go back to my calculator. Okay, so now we did all the work and we got it as simple as possible. Okay, so I literally want to type this and this into my calculator. So let's see. Let's go back to my calculator. I'm going to clear everything. I'm going to go y equals. I'm going to clear my first graph from my previous problem and clear the second equation from my previous problem. On y1, I'm going to type in my first function. So 8 divided by 3, close the parentheses, with x raised to the 3 halves power. Boom. Minus, I'm going to put it in parentheses, x. Mommy, hold on. I'm busy. Give me 1 second. Raised to the 3rd power divided by 6. That should be my first one. On my second line, I want to put the 32 halves. So 32, not 32 halves, sorry. 32 divided by 3 minus 64 divided by 12 Again, your calculator knows how to simplify all this, so you should be fine. Now I'm going to hit graph. I want you to see what happens. Oh snap, I have a big graph that is out of here, out of my window, so we got to adjust our window. This is still adjusted from our previous problem. Okay, so now window, let's adjust our y max. Let's change it from 5 to, let's say, 15 approximately. Let's see what that does there. Okay, so now I can see the top of my graph. And now, do I see the other one? Yes, I see the other one. Remember, my x value, if I go to my x value, my max is 9. So let's go back to my graph. So this is 1, 2, 3, 4, 5, 6. So I got 2 intersection points. I got an intersection point there, and I have an intersection point here. Remember, my graph is bounded between 0 to 4. So I only care to look at the data between 0 to 4. Let me actually screen clip this real quick, so that way I can compare it on my graph and have it here on the side. Boom. Come on. So I want to screen clip this here. My graph is bounded between 0 to 4, right? 0 to 4, so 1, 2, 3, 4. So I'm going to be closer to this intersection. So now on my graph, I'm going to go ahead second and trace. I'm going to intersect. First curve, I want to make sure that I'm closer to this side, right? So my first curve is this whole thing. Yes. Yes. Yes, I want to get close to this side. So now, boom, here's my intersection. So let me actually screen clip this one. This one has the data that I was looking for. Boom. Okay, so let me get rid of this one. Boom, here. Yes, give me 1 second. I'm almost done, mommy. So now I see that my intersection is x equals 1.7641393. So now I can estimate that k is approximately 1.764. And that is my estimate value of k. At that value, k splits my bounded curves between the first half and the second half, okay? Now, I know these videos were a bit longer for 8.4. I think these are going to be the longest videos that you will have as far as the practice goes. Sorry, as far as the packet goes. 8.5 and 8.6 should be a little bit faster. But I would like for you to look at practice problems 1 through 13. Yeah, let's do 1 through 13. 15 from the test prep is a little bit of a challenge, but it's calculator active, so you should be able to figure it out relatively easily. But yeah, do the practice problems 1 through 13. Again, I want you to really try these out. These are very similar to what's going to be on your FRQ exams. So try these out. These are very important. We're heading towards the middle. We're heading towards the middle of our Unit 8. Unit 8 only has about 12 to 13 lessons, and not all lessons apply to us. So when we get back, remember, there's a quiz. But yeah, I will be uploading 8.6 and 8.5 and 8.6 on Wednesday, okay? So hopefully you enjoy the rest of your break, and I'll see you in the next videos.